Welcome to The Explainer. Today we are getting right into one of the biggest questions in artificial intelligence. How do machines actually learn? We're going to break down the two fundamental ways they do it. And trust me, it's way more interesting than you might think. So let's just start with that big question. How do you teach a computer to think? I mean, it can't just pick up a book or watch a video like we can. It needs a game plan, a method for turning just a mountain of raw data into actual, useful knowledge. And it really boils down to two main approaches. You can think of them as two completely different learning styles. On one hand, you have learning with a teacher who already has all the answers. And on the other, you have learning like an explorer who's just sent out to map a totally unknown territory. One is all about making perfect predictions. The other is about making brand new discoveries. Okay, so first up, let's meet the teacher. In the world of AI, we call this methodical, by-the-book approach supervised learning, and it's all about learning from examples where you already know the right answer. Think of it like this. Supervised learning is like cramming for a test using a study guide that has all the questions and all the answers. The algorithm gets fed tons of examples, say 1 million pictures, each one neatly labeled cat or dog. Its entire job is to figure out the rules so it can correctly label a new picture it's never seen before. So what does this teacher actually do? Well, it has two main gigs. The first is classification, basically sorting things into boxes. Is this email spam or not spam? That's classification. The second is regression, which is all about predicting a specific number, like what's the future price of a house going to be based on its size and where it is. And this brings us to the big trade-off. If we were giving the teacher a report card, it would get an A+ for accuracy, for sure, if it has good data. But here's the downside, and it's a big one. It is incredibly hungry for that data. And creating those perfect pre-labeled data sets is super time-consuming and can be really, really expensive. Okay, so if that's the straight A student, the teacher, what about the explorer? This is where we head into the wild frontier of AI, something we call unsupervised learning. Now, the explorer gets no answer key at all. Imagine just being handed a giant, messy, uncharted map of data, maybe thousands of customer purchases, and your only instruction is go find something interesting. The goal isn't to predict an answer we already know, but to discover brand new patterns and structures all on its own. So what kinds of things does it find? Well, its main skills are discovering natural groups through something called clustering, like finding different types of online shoppers based on what they buy. It's also amazing at something called dimensionality reduction. Now that sounds complicated, but just think of it like taking a really complex 3D model and figuring out the most useful 2D shadow it can cast. It boils down messy data to its most important parts, which makes it way easier for us to actually understand. The amazing thing about this approach is that it can find these totally hidden patterns that we humans would have never even thought to look for. But there's a catch. Since there's no right answer to check against, the results can be a lot harder to judge. Did the AI find a genuinely meaningful pattern, or is it just seeing shapes in the clouds? All right, so we've met our two main characters, the teacher and the explorer. Now let's put them right next to each other. Seeing them head to head is where it all really clicks into place. This table just lays it all out so clearly. Look at the rows. For data type, the teacher absolutely needs those labels, but the explorer works with unlabeled data. And that flows right into their main goal. The teacher is all about prediction. The explorer is all about discovery. That one difference, prediction versus discovery, changes the entire game. But here's where it gets really, really cool. This isn't about picking a winner. It's not teacher versus explorer. The real magic happens when they team up. You actually run into the teacher's work all day, every day, probably without even thinking about it. That spam filter in your email, that's the teacher. The fraud alert you get from your bank, the teacher, again. Even the voice assistant on your phone, all of it relies on learning from tons of labeled data to make really accurate predictions. Meanwhile, the Explorer is working its magic behind the scenes. It's the engine that powers Netflix's recommendations for what you should watch next. It's how online stores can group customers with similar tastes for their marketing. The Explorer is the master of finding people who liked this also liked that by spotting those hidden connections. So check this out. Here's how they form a super team. Let's say a company wants to launch a new product. First, the Explorer dives into all the customer data and discovers distinct groups based on buying habits. That's step one, pure discovery. Then, in step 2, the teacher takes over. It uses those new group labels to predict which of those segments is most likely to actually buy the new product. It is a perfect 1-2 punch of discovery and prediction. This quote just hits the nail on the head. This isn't just a technical difference we're talking about, it's practically a philosophical one. Is the main goal of AI to get better at predicting things based on what we already know, or is it to discover completely new knowledge that we never even knew existed? So as we wrap this up, you can see the question isn't really which one is better. It's obvious that modern AI needs both the focus of the teacher and the curiosity of the explorer. The real, mind-bending question for the future is this: what happens when a single AI can master both? When it can seamlessly switch from learning by the book one moment to exploring creatively on its own the next?